In the previous video, I looked at the idea of standard deviation, and now I want to look at calculating it. And while standard deviation is the measure of variation we will use the most, I'm also going to look at variance since it is very closely related to standard deviation. Variance is denoted by s squared, and it's given by this formula here. Essentially the idea, we find our deviations and square them. We then add them up and divide by n minus 1. Standard deviation is the square root of this value and is denoted by s. These formulas can be difficult and complicated with a lot of steps. So we're going to break it into some easy to compute steps to make this calculation a little bit easier. The first step, we're going to need to find the mean of the data set, x bar. We then will calculate the deviations of the data set. So we will subtract the mean from each of the data values, xi minus x bar. Step 3 is to square these deviations. So we'll take step 2 and we'll square each of the values. Next, we'll add the squares of the deviations. So step 3 has a bunch of numbers and we just need to add up all of those numbers. We then divide by 1 less than the number of data values, or n minus 1. And this is the variance. At this point, we do have the actual variance. Finally, we take the square root to get the standard deviation. Let's consider this data set that I looked at in the previous video, 2, 4, 5, 6, and 8. The first step is to calculate the mean, which we can calculate to be 5. Next, I want to find my deviations. 2 minus 5 is negative 3. 4 minus 5 is negative 1. 5 minus 5 is 0. 6 minus 5 is 1. And 8 minus 5 is 3. My third step is to square these values. Negative 3 times negative 3 is 9. Negative 1 times negative 1 is 1. Continue squaring to get 0, 1, and 9. After that, we want to add up these numbers we just found. So we have 9 plus 1 plus 0 plus 1 plus 9, which is 20. We can then find variance by dividing by 1 less than the number of data values. We can see that there are 5 data values here. So our variance is going to be 20 divided by 5 minus 1, or 20 divided by 4, to get 5. Our standard deviation is then the square root of that number, which is approximately 2.236. Let's look at our second data set, 2, 3, 5, 7, 8. Once again, the first step is to find the mean, which is, once again, 5. We then need to find our deviations. 2 minus 5 is negative 3. 3 minus 5 is negative 2. 5 minus 5 is 0. 7 minus 5 is 2. And 8 minus 5 is 3. We then need to square these values. That gives us 9, 4, 0, 4, and 9. The next step is to add up the numbers that we have squared. 9 plus 4 plus 0 plus 4 plus 9 is 26. We can then find our variance by dividing by 1 less than the number of data values. We have 5 data values, which tells me that variance is 26, the number we just found, over 5 minus 1, or 26 divided by 4, which is 6.5. Standard deviation is then the square root of this value, the square root of 6.5, which is approximately 2.55. So our first data set had a standard deviation of about 2.236. This one is 2.55. Since our first data set had a smaller standard deviation than the second set, we can say that the data in the first set is much more compact and centered around the mean than the second data set. This number is essentially telling us how varied our data is. A small standard deviation means the data is very compact and centered around the mean, whereas larger standard deviations tells us that our data is much more spread out away from the mean.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.